this session, we're going to talk about the combustion equation. The combustion equation. To have combustion, we can sometimes call it burning. To have burning, combustion. First of all, you have to have a fuel. Secondly, you have to have oxygen. And third, you have to have a kindling point. That's a temperature at which combustion will occur. Below that temperature will not occur. Okay, so now let's go back to equations in general. Equations in general. The first thing we have to do is get the facts. Number one. Number two, write complete formulas. I hope you're going to get tired of me saying this. 1, 2, 3. And number three, balance. Balance the atoms. So the equation we're going to look at is one with a substance called propane. This is a fact, propane. Propane is obtained mainly from natural gas. A small percentage of natural gas is propane. Propane is the fuel. The oxidizing process occurs through the element oxygen. You can't oxidize things with other things other than oxygen. But for burning, we're talking about oxygen. Remember, this is part of air. We're going to get, if we get complete combustion, we're going to get carbon dioxide plus water. Two products. Plus we're going to get heat. And we have to have some kind of a spark here to ignite this. Okay, that's the first step. Now, the second step. Correct formulas. Propane is a hydrocarbon. A hydrocarbon. That means it's a carbon compound that also has hydrogen. C3H8. And it's going to be in a gaseous form. It's usually shipped by compressed propane gas that makes it liquid. That you can store a lot more gas in a liquid form. It's liquefied at only about 12 atmospheres of pressure because it boils at very low, only a low temperature of about minus 50 degrees. So you can compress it pretty easily into a liquid. 12 atmospheres of pressure is not that much. 12 times the pressure that's on us right now, our body. We're going to burn it with oxygen. The formula for oxygen is O2. It's diatomic. And we'll write a spark here, because we have to have ignition. Propane will vaporize from a liquid to a gas very quickly, so we don't need any kind of a special device like in old cars, carburetors, or ignition systems. It just becomes a vapor. Complete combustion is carbon dioxide, gas, and water vapor. And you're going to get heat, plus heat. Now, to balance this equation, what I recommend is to always start with the largest molecule, the most complex, and this is for combustion, and this is propane. You have 3 carbons on the left. So to get 3 on the right, you cannot put 3 in the formula any place, or you can't put a 3 below the carbon. So you must balance by coefficients. That's 3 carbon. Now, go back, since oxygen is single by itself, balance the oxygen last. So let's balance the hydrogen first. 8 hydrogen on the left, and on the right you have 2 hydrogen and water. So to balance that, 4 times 2 is 8. Now look what you have in oxygen. 4 times 1 is 4. 3 times 2 is 6. That's 10 oxygen. Do you put a 10 over here? No, you already have 2, so you put a 5. And this is 1 understood. So the coefficients are 1, 5, 3, and 4. That's a balanced equation. Propane. Balanced equation. Now let's just go a little step further here. This is oxygen. If you're burning this in air, remember air is a mixture. It's 0.21% oxygen, and that gave us this 5 up here, 5 moles. And it's about 0.78% nitrogen, 78% nitrogen. So we want to find out what this X is. And you can say, well, why are we doing that? Well, the X is, you can cross multiply here, and it's about 18.6 moles of nitrogen. So we could put 18.6 moles on the left. It's available with that amount of oxygen, but 18.6 on the right. So it's not consumed. That's why it's ignored. But that is at room temperature. That's at 25 degrees Celsius. But if you take that nitrogen on the left, we'll get back here again. Nitrogen on the left in oxygen, and get that temperature up to about 2,000 plus degrees Celsius, like in an automobile cylinder at that high temperature, you can get a reaction. So nitrogen and oxygen will form nitrogen monoxide. That's a nasty pollutant, forms nitrogen dioxide. That's why we have to try to stop this from happening, and we use what's called catalytic converters. Just a thought, you see, nitrogen and oxygen don't react. Look up above you right now. You see no reaction with the nitrogen and oxygen, but at high temperatures you can get a reaction. So this is the first reaction. The second reaction we're going to do is ethanol plus oxygen yields carbon dioxide plus water. Whoops, just going fast here. Ethanol is C2H5OH. That's ethyl alcohol. It's used as a fuel, very heavily used in Brazil, made from sugar. In the United States, we're supplementing our gasoline with ethanol made from corn. Ethanol plus O2 yields carbon dioxide and water. This is complete combustion. There's 2 carbon here on the left, so we'll have 2 here on the right. Look at this now, 5 and 1, 6 hydrogen. 3 times 2 is 6 hydrogen, and we have 2 times 2 is 4, plus 3 is 7 oxygen left. Now, how do I do this? Look here. 1 oxygen there. So 3 times 2 is 6, and 1 oxygen makes 7. If you ever got halves, you could just double everything. Okay, this is complete combustion. Incomplete combustion could generate carbon, soot, and carbon monoxide. And we will not include those in it right now, but that's a possibility. And we will stop right there.